So welcome to Tech Talk Thursday, Season 4, Episode 11. True design for manufacturing has been the holy grail for designers and manufacturers alike since the beginning of electronics assembly manufacturing. Here to talk about that and the other enhancements to the PCB Flow platform is Oren Manor, a leading expert within the Siemens Mentor Division. Welcome, Oren. Nice to see you today.
Thank you, Trevor. Nice to be here.
Yeah, great. So let's talk first of all about why DFM is so important to designers and assemblers.
Yeah, well, I think, we all see, the complexity of the designs are going, increasing constantly. The density of the designs are increasing constantly. And, maybe in the past you could do some DFM with, manual DFM, look at the boards, try to analyze it. Today, really doing something like that is very, very, complicated. And really you need an automated way. Also, I think, in the past, if you had a single NPI a week, well, you could do some type of process. But if you have 5 NPIs a day, you can't spend now a day, DFMing your solution. So it's clear that you need some type of solution. DFM has been out there for a long time, but it has required significant investment on the design side to really, build up the process constraints so you have a good simulation and a good testing. And since many designers don't really understand manufacturing processes and don't care so much about the manufacturing process, doing this in the design has been, a challenge. So I think the big enterprises have solved this by bringing experts, right? Manufacturing experts over to the design side. But the smaller ones have been struggling to do that. And really, I think, now with PCB Flow, we do bring that type of DFM solution also to smaller companies as it requires really less investment and less setting up than, classic DFM solutions.
Right. So how does PCB Flow then help to close that loop of information back?
So really, So PCB Flow is really a bit of a marketplace in that sense because it allows manufacturers to publish their constraint sets on the platform. So if I'm a manufacturer, and I have 2 sites and I have, let's say, 6 lines in each site, I can go on PCB Flow, create my profile, and I can upload my constraint sets. Now I can do multiple ones, one for low density, one for high density, one for medical, one for communication. I can do some which are private, which means only by invitation can somebody use them. I can do ones which are public. And in any case, the designers don't see my constraint sets. All they can do is upload their design and select my constraint sets to run and get a report.
Right.
So my IP, my know-how, my manufacturing processes are confidential, they're kept. But me as a designer now, I don't have to try and, reverse engineer it. I don't have to try getting PDFs and try to set up this. I am guaranteed a very accurate DFM analysis, up to date, and, matching as closely as possible the manufacturing process, which I'm, going to use in the future.
So presumably the outcome of all that's going to be you're going to have less design turns before it gets into production.
Exactly. So let's say I'm going to look at 3 different providers. I'll DFM it. I'll see the issues. I'll fix them. When I actually go and award the business to one of these contractors, we shouldn't find anything. We shouldn't have any iterations. What would happen in the past is I would do a DFM on the design side, like a generic DFM, based on some, generic manufacturing constraints. It was all good. But then when I went to actual manufacturing, the manufacturer would run a DFM with his specific process constraints and find all of these issues. Well, now we can really avoid this because the DFM is much more matching the actual manufacturing constraints, which are going to be subject. And then, these 2.5, 3 iterations between design to manufacturing should go away, which, me as a designer, really what I want is to get these products manufactured as quickly as possible. I want to validate them, and then I want to go into volume manufacturing. And this really should help me accelerate, this whole NPI process.
Yeah, absolutely. So, there's a lot of AI coming into these systems now. What role do you think AI has to play in the future development of this area?
So, definitely, we don't want to start, maintaining all of these DFM rules and doing this manually. We do want, at the end of the day, some type of machine learning and AI algorithm to help us in doing this type of detection and doing this type of optimization. And also, we want somebody to be able to run multiple DFMs and not have to look at 6 different reports now from all of the different manufacturing constraints that he used, but try to get some type of aggregated report that helps him know that now his design is ready for all of these different manufacturing sites and manufacturing processes, and he can get a very, accurate representation. On the other side, the manufacturers, at some point, they've got to quote the business. Now, quoting on the manufacturing side has always been an issue. And you want to do very accurate quoting, but very quick. So also here, once you do this DFM and you find the issues, this can also help you with some specific AI algorithms generate a very accurate quote, which takes into consideration the actual manufacturing process, anything specific you're going to have to do, any specific testing, manual insertions, anything like that, which would make the production a little bit more expensive, allowing you to, at the end of the day, generate a very accurate quote.
Right. Okay. So you've also recently introduced a new BOM validation tool. I think it's called SupplyFrame.
Yes.
Can you tell us a little bit about that?
Sure. So Siemens did a very major acquisition of SupplyFrame about 9 months ago. SupplyFrame has, the ability to really provide both designers as well as manufacturers with very up-to-date BOM availability and BOM pricing. And of course, one of the things that you need to do when you're designing is really understand these components that you've selected. Can I actually source them? Can I get them? What type of supply form are they going to come in? What's the price? And today, in these really times of, shortage of components, this is extremely valuable. So on PCBflow now, we're also going to be providing this type of supply frame insight, allowing both the designers and the manufacturers to understand whether they can actually source these components. Now, in the design, you might be doing the design in Canada. You can see that you can source this in Canada, but if the production ends up in Malaysia or in Romania, well, maybe you cannot get those components today in these types of locations. So then PCBflow will help manufacturers look at that type of BOM and understand, okay, what's the availability? Are any of them very close to end of life? Should they be worried about them? Is there any risk with using these components? What are the prices available, with the different distributors, whether it's DigiKey, Avnet, and the likes? Mm-hmm. And then allows me also to look at alternatives and recommend some alternatives, telling you this component actually is going to go end of life in 4 months. If you're considering a long program, we suggest moving to an alternative component which has the same fit, function, and form, but has much better availability.
Right.
So this really adds in another thing that Siemens until today wasn't really a player in, this whole supply chain components availability. SupplyFrame really puts us into that domain and allows us to bring this additional derivative to the solution.
Yeah, it's such an important area these days, especially with the supply chain problems we're having. I mean, how does this work? Does it embed APIs into the suppliers' systems so that you're getting real-time information?
Yes. So basically, SupplyFrame has a backend which connects to the different distributors. Some of them are real-time, and there's a real-time synchronization to their inventories and their pricing. Some of them upload files, let's say once a week, uploading their assets. So the big ones are all fully connected and in real time. Some of the smaller ones might be, uploading files every couple of days. And of course, me as a customer, I can log in and provide my specific login and password for the different distributors. So when I see prices, I actually see my negotiated prices. So I'm allowed to see, what I've negotiated with DigiKey or Avnet, not the general public prices, but my actual prices. And this also allows procurement to really try as much as possible to procure from preferred suppliers, leveraging these types of contracts, because we've seen many cases when we've done research that while you have an agreement with DigiKey, procurement ends up buying from other places and, finding other alternatives. So this also allows, procurement to really try to streamline everything through the preferred suppliers.
Right. Now, well, one of the other issues that's been actually increasing over during COVID has been the problems we've had with counterfeit. And of course, if you go down to the grey market to get hard to source components, again, you're running into that issue. But you've recently brought in some or acquired some software to help challenge that called
Yeah, so we have a
Cyborg.
partnership. Yeah, we have a partnership with a company called Cyborg. So we are going to be the the exclusive reseller of the Cyborg solution, and this is also fully integrated into the Siemens portfolio now and the Siemens solution. And really, what Cyborg allows us to do is do some type of authenticity validation for the different components. Now, this is primarily running on the placement machines. So the software knows how to connect to the different placement machines, get the actual images before placement from the alignment camera, and then using AI algorithms and a very big library on the cloud, see whether this component is authentic or maybe has different issues of counterfeit. It might just be very old and sold as new. It might be a different vendor. You bought for vendor A and it's actually a vendor B. And it might be, multiple vendors on the same reel mixed up, which of course has many implications on your traceability and your recall, because you're assuming all of the components of the reel are coming from the same manufacturer. Right. It also allows us to do these spot buys. So if you're missing components, you have two alternatives. One is to do a design change and go with a different component. Might be slightly different, which means you have to maybe alter a little bit your design and your manufacturing process. Another thing is to do some spot buys and go to try to see, on the market, who has some of these components, maybe some other OEMs. And then, of course, you really lose the whole traceability. You don't know where these components have been, how they've been kept, what type of, humidity, temperature. Well, now you can use the Cyborg solution to take these, 5,000, 10,000 components, analyze them on the side with a special camera, and validate that they're really authentic, and then push them into your manufacturing area. So this really opens up the ability to do these types of things, because, we see, a drastic component shortage. And, just now we saw the announcement from Apple, they are even suffering from these component shortage, on the iPhones. So, if Apple is suffering, of course, all of the smaller players are really struggling to find components these days.
Yeah, absolutely. And it's really pushing out lead time on delivery of equipment and all sorts of problems into the market. One of the things that you'll get, I'm assuming though, with this Cyborg is that if you've got components of different geometries or different sizes, maybe they've replaced the reel halfway through a shift and it's come from a different supplier. It's the same value, of course, but it's slightly different geometrically. Does it pick up things like this?
Yeah. So it definitely picks it. So it can see a slightly different body size, maybe slightly different pin location. So any type of geometric, it can detect. Of course, it also looks at the marking and any type of marking. It can also detect, ability if somebody tried to flash the device, if it's some type of IC or microprocessor. Maybe somebody has tried to inject some type of malicious code. Yeah. It can also see that type of stuff. And it can also see, that the pins maybe are not in such good condition, which might provide some solderability issues. Right. So it's looking at a lot of things and really trying to say that this component is coming from the actual vendor, is in good shape, is new, and is from the same lot, and is really giving you a higher level of surgical traceability than we do with the classic MES systems. The MES systems are always, at the end of the day, you scan the reel, you scan the barcode. Yeah. If you miss one scan, all the data messes here. Yeah. Here, the scanning really doesn't matter. It's all based on images, and you really get a report from each reel, giving you each board exactly which components have been placed, validated, and also can provide some type of ranking to the PCB based on the different component ranking, and say, okay, this PCB gets a 95% rank because a few components looked a little bit suspicious. This guy gets 99 and this guy gets 60 because we've had a couple of components which are really, troubling. And this is probably also pre-reflow. So while the components have been placed, the system is quick enough to notify you really in a couple of milliseconds, and you can really stop the production, take out the PCB, put this reel, send it to some lab, and continue production with some different material.
Wow, it's incredible how much it's moved on in such a short time. Finally, my last question to you, Oren, there's so much we wanted to talk about. Siemens announced very recently that it's launching an XaaS platform. XaaS is their abbreviation for SaaS, which is software as a service. Why is this so significant, and what benefits is it going to bring to designers and manufacturers?
Okay, yeah. So the new platform is really Accelerator as a Service. So the old platform was Accelerator, and now Accelerator as a Service is really the cloud offering. So, a lot of our customers are using very, I would say, powerful on-premise engineering solutions. But we all understand that we need to be connected. We need to be able to, communicate with our manufacturing partners, with our ecosystem, and we cannot live in silos anymore. And that's why really Accelerator as a Service starts connecting these different applications, with other parties in order to really allow this type of collaboration. Right. And PCB Flow is really part of our Accelerator as a Service for electronics offering. So it's really part of this program of, starting to connect the different applications together and provide this type of collaboration. And as an example, PCB Flow, after you do your DFM analysis, you can start communicating with the manufacturer. So instead of emails and Excel files, and the iterations are actually done on the platform, easy to read them. And once you want to get a quote, you can request the quote on the platform, receive it on the platform, and basically issue the job on the platform. The CAD files, the BOM files are already up there. All the manufacturer has to do is download them and start manufacturing. So that's an example of where we're doing this. Now, we're also connecting this to some of the on-premise applications. So, for example, our legacy DFM solution, Valor NPI, which is used by a lot of tier ones, can also communicate with PCB Flow in order to get up-to-date constraint sets. Mm-hmm. So we're also allowing, the enterprise customers, the big mil-aero contractors who have been doing DFM for years to benefit from this Accelerator as a Service by being able to get up-to-date data and get, for example, data coming from supply chain regarding availability. So I think designers today understand that they need to be connected to the cloud in order to get real-time information, benefit from this cloud computing, while doing some activities which are, very, resource hungry, such as layout, such as design, still doing them, on-premise, because of IP issues and these types of issues, but benefiting from this type of, data that's available on the cloud and, algorithms which will run better, much better on the cloud.
Right. I mean, I would imagine that some of the companies that are doing military manufacturing and stuff like that, they're constrained by these new CMMC regulations. They might find it difficult to connect to a cloud system. They might still have to maintain an on-premise system. But they have the ability, as you just said, to be able to connect to updates, to get validations through and that sort of thing.
Exactly. Yeah. So they would never load up their design to the cloud, but they might be able to download the constraint sets and run the simulation on premise, or get validation to some availability of pricing or stuff like that, which is something that's permitted. Yeah, but still keeping and of course guarding their IP and the sensitive design that they're doing there.
Right.
Yeah.
Exciting times, Oren. Honestly, it's incredible how quickly this is moving forward, and it must be a fun place to work right now.
Yeah, I think, we're finally moving, and we're finally understanding that, while maybe we cannot take all this, 25-year technology and move it up to the cloud in a day, we can still provide capabilities on the cloud, connected to these on-premise applications.
Yeah.
And that's probably, the big differentiation. And, the smaller players, the startups, the SMBs, these guys, have less to lose. They don't want to invest in servers and start buying, a lot of on-premise software. They can do a lot of the stuff, on the cloud immediately. And this really allows, somebody with 5 years of experience, maybe, in, let's say, simulation or DFM, benefit from 30 years of experience. Yeah. So I think that's one thing that the cloud allows us to do, is really, help these younger people in the industry benefit, because they don't have the 30 years of experience. But since our algorithms are so good and, we can do a lot of this type of AI, we can really provide them with, the benefits of, 30, 40 years of experience.
Yeah, absolutely. It's superb. So I guess you're over in California at the moment. I guess, are you going to be heading to Productronica?
Yes, we are. We will be exhibiting in Productronica. It was a bit of a debate internally. Should we exhibit or should we not exhibit? Really, nobody knows what to expect. But we will have, presence at the show. We are looking forward to, after 2 years, meeting our customers there and meeting a lot of the partners. And I hope it's going to be a successful show and we get some good turnout.
Yeah, absolutely. Well, we've certainly got a big program on there as well. So no doubt we'll look forward to seeing you over in Munich in a few weeks' time.
Yeah.
Okay. Thank you for joining us today, Oren, and the best of luck with this new...
Thank you, Trevor. Thank you for your time. Thank you.
Global SMT and Packaging opens the windows of the world to bring you the latest news and technologies from Munich, from Bangalore, from Shanghai, from San Diego.